Hey, I hope you're doing well. Today I want to talk a little bit about a process called check digit schemes. ISBN numbers, UPC codes, they all follow a scheme. These numbers aren't just arbitrary. There's one number at the very end of these, like for ISBN. There's a check digit, the last digit in the number. So in this video, I want to talk a little bit about how we go about doing or computing these check digits. So I have some stuff written already, and I want to talk about this. I'm going to go through this slowly. And if you look up here, yeah, this is part of a project. You'll be getting a lot more information on Friday about this. So ISBN scheme. ISBN numbers, there's 10 digits in them. I wrote down 10 digits here. This last digit I made a little bit larger because this is the check digit. Now, this is an actual book. It comes from a book called Foundation's Triumph. This is part of Isaac Asimov's Big Foundation series. And this is the actual number on the back of the book. It ends in an 8. This 8 is not arbitrary. So I want to actually sit down and do some calculations and show you how I got this. So how do we calculate it? Well, ISBN number is a standard thing. And each one of these is associated with a weight. So what I did here is I wrote all these numbers down except for the last one, 006105241. Now I want to put down integers decreasing by 1, 10, 9, all the way down to 2. So I'm going to put a little dotted line right here, and I need to figure out what this n is. That's going to have a weight of 1. As we are going to compute, it's going to turn out to be 8. But why is it going to be 8? So if I do all these multiplications, and then I add them all up, that's what the sigma means. I get 102 plus n. Now, ISBN scheme says this sum, including the check digit, has to be 0 mod 11. Well, think about your multiples of 11. 111. Sorry, 110 is a multiple 11. What's the smallest positive integer that can actually get, I should say not positive, I should say non-negative, integer that gets you up to the next multiple of 11? 102 plus 8 is 110, and that's why this is the check digit for this particular number. Now, why is it a check digit? So I want to do something here. I want to take these two numbers, and you can do this with any two numbers in here, and I'm going to flip them. So the 5 and the 2, I want to make this a 2 and a 5. Suppose you were typing something in, and you accidentally transpose this. This is called a transposition. So that would take this 5 and the 2, that would be a 2 and a 5. Instead of having a 25 and an 8 here, I would have a 10 and a 20. This goes down by 15, but this goes up by 12. So this number goes down by a total of 3. So my sum is going to be 99. And now if I add 8 to it, I get 107. Is this a multiple of 11? It is not. So therefore, if I choose 00610254118, if I accidentally switch the 2 and the 5, when I do this weighted sum, that's what this is called, it doesn't turn out to be 0 mod 11. So this particular scheme catches an error called a transposition. Now, there are lots of other errors, and I'm going to give you a document to read about, or to read about all these things. And in this document, there are various different types of check digit schemes. UPC codes, at the back of a food product or any item that you buy. Those are UPC codes. They have a certain scheme. UPC codes, that's called a 3-1 scheme, where instead of the weights being 10, 9, 8, 7, they just alternate 3-1, 3-1, 3-1. And that's a mod 10 system. Then there's the IBM check digit scheme, which is actually something that we use all the time. It's the credit card digit scheme. The first day of class, if you can think way back to the first day of class, I talked about check digits. I didn't use that terminology, but I said we're going to be able to create our own credit card number. And that's what some of this is all about. So I'm going to leave it here and make this video very short. And we'll talk more about this on Friday. I hope you're doing well. Talk to you later. Bye.